Now let's do something interesting. So far we didn't have any interaction with the game. So in real application, user has to interact with the game by various means. For example, user can tap on the screen or touch on the screen. User can drag, user can tap, double tap. User can do many things. User can press buttons and so on and on. So what I'm going to do right now, is our rectangle component will be at the center of the screen, and we will not update its position by itself. Instead, I will click anywhere on the screen, or I will tap anywhere on the screen, and whenever I tap on the screen, then our rectangle component will move to that position and maybe stop there. So what we need to do to achieve this kind of scenario? First of all, we need to do something so that our game can identify that some event has occurred. For example, some tap event or touch event. And there are various ways to do that, but the simplest one is we need to tell our game, in the main game class, we need to tell our game that it should now intercept the tapping or the touch on the screen or the game screen. And to do so, we have to add a mixing to our myFlame game or the main game class. And we can do so by simply saying with, and we have an interface or class which is tap callbacks. So we have this tap callbacks. So by adding this mixing to our game, now the game will understand that it should interpret any tapping or touching on the screen. And since we have added something to our game, there are multiple or various methods and properties that are automatically inherited, or we can use those properties or method of this tap callback inside our game. So one method we need to override right now, and I can see that we have an update method inside our game class. Since it is useless right now, I'm going to delete this. We don't want any unnecessary override. Instead, I'm going to override another method that will be coming from this tap callbacks, which is on tap. You see, as soon as I start typing, we have various suggestions that we have on tap cancel, we have on tap down, on tap up, on long tap down, etc. and etc. So I'm going to override this one on tap down. So whenever we put finger on the screen, or when we put our cursor, when we use a desktop or mouse, when we click, then every time I click or touch on the screen, this method will be called, and we will be given some object like a tap down event object, and we can find the exact coordinate where we have actually tapped. So if I tap here, then we need to know the position, the X value and the Y value. Then we have to calculate the target position with the current position, do something else. So how we can get the tapped position? It's very easy. Let me print. We have an event object. So we can say event dot. So we have many things, but we have one thing which is called local position, which is also a vector object. So now if I start this application and open the console, and now if I touch anywhere on the screen, for example, if I tap here, you see this is the point 183 by 111. So along the x-axis it is 183, along the y-axis it is 111. So if I tap at the bottom corner of the screen, it says it is 1026 to the x and 645 to the positive y. So now we can have the tap position. Now all we need to do is we need to move our position or my rectangle component to the tapped position. But currently, with the current settings, our rectangle component is moving by itself because we have provided a velocity of 1 by 1. So it is moving like diagonally to the bottom right corner. What we can do is we have defined this velocity at the top of this my rectangle component class. What we can do is we can say the initial value of this velocity would be 0. That means x will be 0 and y will be 0. So now if I restart this application, now we'll see our position component or our rectangle component is not moving at all, because now the velocity is 0. So we are adding whatever we are adding or multiplying with this 0 vector, it actually results in 0. So no movement at all. So now all we need to do is, for example, if I click here, if I click at this point, then I want this rectangle component to move at some speed to exactly this position, or at least move towards this target position. How can we do that? How can we do that? To do so, let me define a method inside our my rectangle component, because we need to somehow change the velocity value. So initially this is 0, but we need to calculate and we need to have a velocity so that this rectangle component's position can move according to this velocity and speed. So speed will be fixed, it is 50, but velocity will be changed. And of course, we are only interested in the direction, not the magnitude of x and y. So I'm going to create a method called like say move to target. And when we call this method, we will pass the tapped position. So that would be vector2 and target. And whenever we tap on the screen, we know this method will be called on tap down, and we get the position, and we will pass this event.localPosition to our myRectangle component class by calling this method move to target. So let's go to our game class, and instead of printing, okay, let it be there, we want to now call this method. So to call this method, so this method is a part of this myRectangle component, and it's not a static method. It's a method. If we want to call this method, we need to create an object, or we need to have a handle or reference of this myRectangle component. But currently we don't have a reference of myRectangle component, because inside this add method, we are directly creating the reference of myRectangle component. To do or to have an object or reference of myRectangle component, what we can do is we can declare a variable or reference of type myRectangle component. Let's say let, and say myRectangle component, say MRC, myRectangle component. And here inside this add method, we are saying MRC equals. Okay, so now this time the object of this myRectangle component will be created and will be stored inside this reference MRC. So now we have a handle of this object of this class. So we can call MRC.move to target, and we can simply pass event.localPosition. And what's the problem? Maybe I have misspelled. I mean, the method name would be move to target. So this one, T will be capitalized. So let's say this one. Okay, so whenever now we tap, we are passing this local position or the tap position to the myRectangle component class by calling this move to target. So now what we should do with this target, how we can move this myRectangle component to this target position. To understand that, I have a visual like a diagram for you. So this is the visual diagram. And let's say that we have a screen. So this is the game screen. Okay, so this is 0, 0, and the game screen is 800 pixel wide and 600 pixel tall. So this is 0, 0, and this is 800 by 600. And let's say this is our target. This is the target point. This is where we tapped, and the point is 200 by 100. And this is our rectangle component. And the position is at the center because the anchor was center, and the rectangle component's current position is 400 by 700, for example, because it is at the center of the screen. So 800 divided by 2 is 400. And let's say roughly this point over here is 700 along the positive y-axis. Now we want this rectangle component to move to this point. That means the anchor of this rectangle component should be here. So rectangle component should be somewhere like this one. over here, something like that. Okay. So how we can calculate? So first of all, we need to calculate the direction. I mean, at which direction this rectangle component should move. And to calculate the direction, we need to subtract the position from target and the current position. That means what we need to do is, first of all, we need to get the direction object, and we can get the direction object or direction vector by subtracting position from target. So we know the target is 200 by 100 and the current position is 400 by 700. And if we subtract these two vectors, so corresponding axis value will be subtracted. That means 200 minus 400, that will be minus 200. And 100 minus 700, that would be minus 600. That means this component should move minus 200 along the negative x-axis, and it has to move minus 600 along the y-axis, and then it will reach at this position. And also we need to know this length of this vector. So this is x and this is y, and now we need to know the length, and we can think of this as a right rectangle, and this is the hypotenuse, this is the opposite, and this is the base, and we can easily calculate this value by applying Pythagoras theorem. I mean 600 square plus 200 square and square root, if we get this value approximately. So the direction or the magnitude is 632. Okay, but if we move this current position, or if we move this rectangle at this magnitude value, it will be very, very fast. In the previous example, I told you that in such situations we actually deal with unit vector, because we are not actually interested in the magnitude but with the direction. So we only want to know the direction. That's why what we need to do is we need to normalize this direction to convert this direction to a unit vector, so that the x value would be 1 or near to 1, or the y value will be 1 or near to 1, and this magnitude sign will be there. So there is a method we can call over a vector which is normalized. So what normalized does is it actually divides this value by this one. So if I divide 600 by 632, we get this value. And if we divide minus 200 by 632, we get this value. So these are like very low values, 1 or near to 1. So if we normalize the direction, so this is the direction vector, and we want to convert it to a unit vector by calling this normalized method. So this direction vector minus 200 and minus 600 becomes minus 0.94 and minus 0.31 if I have done the calculation correctly. Okay, so if we have this velocity, then we need to update the velocity with this one, and the update method will be calling per frame changes. So the velocity will be 0 initially, and then we need to calculate the new velocity, and then the component will move based on the new velocity. So according to this slide, first of all, we need to deduct the current position from the target position. So let's do it. Inside this move to target method, first of all, we need to calculate the direction first. So let's say final direction. So that will be a vector. That would be target minus position. So we are subtracting the current position of the component to the tapped position, and this will get some big x value and y value, and we need to normalize this. What you can do is we can now say the velocity that we have defined at the top of the class. So it is initially 0, and that's why the component is not moving. So the new velocity would be direction dot normalized. So it will convert the direction to a unit vector, that from where we can get the direction, not the magnitude. And the error is all about because we have defined this velocity as a final value. So let's remove this final value, And now we have this velocity. So now if I run this application, so it is at the center. And now if I click, you see that our rectangle components start moving towards the target position. And when it reaches, it will not stop because we didn't say anything where to stop. It is actually keep moving because it has got the new velocity, and according to the new velocity, it is actually moving to that point. So if I run one more time and click somewhere else, for example here, so you see the position is changing, or it is moving towards the target position. So what if we want to stop the component at the target position, or as soon as it reaches the target position? We can also do that, and I'll show you in the next lecture.